Hello, everyone. Welcome to the Ieee Sjce Alumni Podcast. Today, with us, we have Akshay Kirshnan, who's a computer vision engineer at Waymo, and he started. He graduated from SJCE in 2018. So let's find out what Akshay has been doing since then, or like what Akshay did when he was when he was at SJCE, and how, and just basically get to understand his story. So Akshay, can you tell us a little bit about yourself? Like, what have you been up to lately, and what are you doing currently?
Hi Naresh, and hi to everyone who's listening. I graduated from SJC in 2018 from ECE, and then I went on to do masters at Georgia Tech, and along with Naresh as well, who was in the same batch as me at SJC as well as Georgia Tech, and I was really into robotics and computer vision, and I graduated from my master's this year, like in May, and now I'm working at Waymo, where I work on computer vision for self-driving.
That's very cool. Thank you, Akshay, for giving us an overview about yourself. So, how does it feel um, to work at Waymo, and considering that you were really interested in robotics and computer vision, and Waymo is one of the companies that is doing cutting edge work in self driving, which at the fundamental level is makes use of computer vision and also a lot of aspects of robotics. Correct me if I'm wrong there.
Um, yeah, that's true. It feels really nice. On a lot of occasions, it feels very humbling to work with really good people. Um, I I get to learn a lot in a wide range of areas, starting from like computer vision. We do both like geometric computer vision, which is like the classical computer vision, and also like deep learning. We use a lot of compute, and there's also a lot of things I get to learn from robotics and like behavior planning, how to model pedestrians, things like that. So yeah, it's a wide range of concepts that you get to learn, and it's interdisciplinary. So you work with people of different interests. Um, it's nice.
So, how did you get interested in robotics? I mean, your uh, bachelor's was in electronics and communications, and like, was robotics the reason you got into that field, or was it the other way around? Can you tell us how you felt this is where you are gravitating towards, and what aspects got you interested in them?
Yeah, I think I got interested in robotics because I was in ECE. So uh, at some point, I realized that I'm not really into circuits and I'm not really into hardware. Um, I liked software better, but then I didn't know which part of ECE would help me. So that's when I started learning subjects like control systems and digital signal processing, image processing. So I really like these courses which had a lot of math, and robotics was one field where all of these concepts got applied. And so we started participating in like robotics challenges and things like that. And at that time, I didn't really know much about robotics. I was just kind of really driven by this amazing technology and like really cool projects. So so yeah, it started because some of the courses that I took and I liked were used in robotics, and that was the part of ECE that I liked most.
So, like, the courses, like, what courses were these? Like digital signal processing and image processing and control systems.
Yeah, so if you think of robotics is a very interdisciplinary field. basically for a robot, you need to have mechanical engineers like designing the robot, and
Mm-hmm.
then you need to have people from controls writing like the control software, where you decide, okay, how much control input do I give to like move my arm of the robot so much
Mm-hmm.
to hold this object and things like that. And then you have computer vision engineers like me saying, okay, the robot has some cameras to learn about the world around it. What kind of things does it have to learn, and how to design its perception system? And and then there are AI engineers who think about like, okay, this is the input we get from perception. How do I act accordingly? How does the robot act accordingly? So it's very interdisciplinary in that respect,
Mm-hmm.
and so this might tell you that a lot of concepts from controls obviously is very crucial to robotics, and then there's DSP as well somewhere. Image processing definitely in it's a part of computer vision. So yeah, that's how I got started in robotics.
So you got started with the controls aspect, and now you have moved on a little bit towards the perception aspect. Is that right?
Yeah, that's right.
Okay. So how was your introduction from the controls aspect? Like, was it purely out of interest? Was it purely out of like you learning these courses that were taught during your undergrad, and what aspects of these courses helped you in understanding what you wanted to understand?
Um, so controls, I think, so when we were taught in classes, it was just mostly theory. And I
Mm-hmm.
think having a good application, a good project in robotics to work on kind of helped me understand the theory better. That being said, we didn't really use a whole lot of controls. We are taught only the very fundamentals in undergrad, and like we didn't even use that much. Like we use, if you're familiar with PID controller, that's what we were using for most occasions. Um, we were doing more innovative things in like AI and perception, and that's how I kind of levitated towards perception because in image processing you could do more interesting things in undergrad, like with my undergrad knowledge. Of course, controls is also after I think in my masters I realized that there's much more to that field, and yeah.
Okay, okay, that's very informative. So you keep mentioning about projects, like what kind of projects did you get on where you could, like apply a lot of these controls and the PID controller that you said you designed? Uh, what avenues did you find during your undergrad to apply and learn more?
We were participating in this competition called the Yantra robotics competition. It's a national level robotics competition, and it's hosted by IIT Bombay. I'm sure there are people in the current batch as well who are still participating in it. It's really interesting, and they managed to. There are, I think they have different tracks. One in which you can propose your own idea, and another in which they define the task and you have to sort of implement it. And they also give you all the materials and stuff. So it you have to put less effort like looking for materials. Um,
Mm-hmm, mm-hmm.
so yeah, the competition for me was really interesting. I also got to work with like great teammates, and I enjoyed the teamwork and the enthusiasm of working in that competition.
So the materials that you spoke about, like they are the ones that are kept in the robotics lab in the admin block, right? Is that
Yeah.
the one?
So that is an Yantra lab. So I
Okay.
think so they do have some robots there that did not really come from Yantra. I think the college got it from various sources of funding.
Mm-hmm.
But every year, as more students participate in Yantra, like you get more components and materials, and they get kind of added to that lab.
So you were the first Yantra batch from our college. Is that right? I mean, before, like when you were in third year, when you were in second year, there was no Yantra, and before you, there was no Yantra in college.
Yeah, that's right. So I think the first time people from our college participated was when I was in third. There were some of our seniors participating too.
Okay, okay, okay. Hmm. So you got a chance to participate for 2 years.
Yeah.
So how was that experience? Like what how was it in first year, and I mean when you were in third year, and how was it in your fourth year, and uh, what was the major difference that you could use from your third year to fourth year in applying in Yantra?
Most of these courses that I told you about are generally taught in our third year. So people who participate in third year itself um, won't really have the knowledge that you get from those courses, like image processing,
Mm-hmm.
at least in ECE. They'll
Mm-hmm.
have to do more of their own research to like implement things, which is also
Mm-hmm.
interesting. And I think our juniors, when we were in fourth year, did a great job of with it. So
Mm-hmm.
you can still do it, but I guess we were not so good at it in our third year. At least, like we couldn't go to the finals of the competition, so we tried again in fourth year. Ideally, if you do really well in your third year, then there's lesser to learn in your fourth year from the competition.
So you
And
went to the finals in fourth year.
yeah,
So how many teams were there along with you, and how many teams participated across India, and how many qualified for the finals?
um, so there are different tracks in this competition, so or themes maybe. Each
Mm-hmm.
theme has a different task, and I think they shortlist like five teams or six teams from each theme across the country.
Mm-hmm. And then you go to IIT Bombay and you present your work.
Yeah, I don't know how exactly the shortlisting is done. In some teams, there are more teams. Basically,
Mm-hmm.
they say that if you complete all the tasks before the final round, then you
Mm-hmm.
should be good to qualify. Sometimes, if too many teams end up doing that, they might have like an additional round to filter or something.
Okay, okay. So interesting. So at in the finals, they don't want a lot of crowd there so that it's easier to judge.
Yeah, maybe.
Okay. So that's very informative, and I'm sure Iantra has helped you a lot uh, in your pursuing your interest in robotics. So taking that learning, let's kind of like pivot into more getting to understand what were you into in your first and second year of engineering, and how did you start coming directly from 12th? Like what was your expectation, and how the first year of engineering turned out to be, and was it a complete disaster you felt? Was it, you know, you felt it was like really amazing than what you had expected, or was it somewhere in between?
First year, I think, was just fun. So we were just having fun. Um, I had not too many expectations coming in from 12th. Um, Basically, I took ECE because like I liked some of the electrostatics and electromagnetics that we learned in PU. It
Mm-hmm.
might be a bad reason to take it, uh, but yeah, that's the reason I took ECE, and I just wanted to be a good engineer. At some point, I felt like I this might not be the last degree that I pursue. I kind of had a very vague idea that I might study further, but
Mm-hmm.
nothing more than that. First year really Yeah, I don't think I made like great technical progress or anything. Just trying to do well in internals and things like that.
So you said like coming to EC, expect having expectations about electrostatics and the physics aspects of what you learn in PU is a bad idea for you. Like, what do you think would be a good idea? Like, are you disappointed with what you got in ECE, or are you disappointed that from an electrostatics perspective, where it misled you to get into ECE and you would have done something else, or how can you throw some light on that?
I'm not dissatisfied with ECE.
Mm-hmm.
Like I mentioned about controls and all that, there have been great courses that have helped me. Um, but whatever I thought I would do in ECE, I did not end up doing. So I think that's okay. Most people change their interests over time.
Mm-hmm.
Um, Ideally, before you start your engineering, it would be nice to like really know, maybe talk to people who are studying that branch and discover like what are the opportunities in that field of study, what kind of jobs do you get, what are the subfields that have more promise in the future, and maybe explore well about all branches. But like most people, information to me at that point was also limited.
Mm-hmm.
So I kind of went with my gut. At some point, I was equally inclined towards CS as well. I kind of didn't have a super convincing reason to choose ECE.
Mm-hmm. So you wanted a little part of electrostatics as well, and you wanted to learn a little bit about computer science as well. And EC seemed like a good bargain for you because it had a mix of both. Whereas if you had chosen purely computer science or purely electrical engineering, you would have to, like make do with only one.
Yeah, that was one reason. There were some other reasons why I did not take CS as well. I
Mm-hmm.
don't like some of the things even now in software, in pure software engineering. Um, so things like say databases or front end, I don't enjoy doing this as much. So
Mm-hmm. Okay, okay. So you're not interested much in the systems side of computer science rather than more of what comes on the application layer, whereas like you can do perception, where you can apply the principles of controls engineering via software or something like that.
systems is interesting. I
Mm-hmm.
like the backend software where you're writing like C++ code to
Mm-hmm.
implement great algorithms, like just thinking about like computational feasibility, scalability, and like designing good algorithms. I do like that, but what I like more is like applying math,
Mm-hmm.
writing software that uses more math and like implementing it on a physical system. So that's more of what I enjoy the most.
So that's a good thing you bring up math. How useful is math, or like how important is math for what you do right now as a perception and a computer vision engineer, and how important is that to be relevant or like to understand the technologies and the breakthroughs that are happening in the computer vision and robotics arena?
Um, yeah, that's a good question. I think math is very important. Um, in computer vision and robotics uses they use different kind of math. I mean, different areas of math are more important for each one. So if you're in computer vision, definitely like linear algebra and statistics is something super important. Um, like deep learning is a lot of like statistical theory that
Mm-hmm.
I think you'd know this as well. So yeah, those two subjects are very important for computer vision. For robotics, also calculus. Calculus maybe. slightly lesser important. I'm not saying it's not important, slightly less important for computer vision, but very
Mm-hmm.
important for robotics. Like,
Okay.
yeah.
So you bring up linear algebra there. I remember. I think our batch, and probably I don't know if it was one batch after us also. Like we are the only two batches probably that the college decided not to teach linear algebra for our third year. If you remember, like ECE folks study maths for 3 years. The rest of the college studies it for 2 years, and our batch was one of the two batches probably that studied math for only 2 years. So, do you think that was a bad decision from the college's side?
Uh, yeah, that's right. I don't know if it was a bad decision. I'm sure they had their reasons to do it.
Mm-hmm.
Personally, I think it would have helped me. I don't know about the others. I'm sure I had like a lot of classmates who are not interested in the area.
Mm-hmm.
Maybe that's why the college considered not offering. I would say the department, maybe not
Yeah,
the college.
correct,
So
correct.
maybe that's the reason they considered like not offering linear algebra. We did have it as a small chapter in one of the math courses in second year, but I think we that got like 2 weeks of time, which is a total injustice to linear algebra in my opinion.
Hmm. So, so you're saying if you want to get into the field of one of these, like robotics or control systems, or even a little bit of computer vision, also, like linear algebra is a very important tool, and you will definitely make a lot of use of linear algebra, and it's very helpful if you know that.
Yes, I don't want to discourage people who are not into math.
Mm-hmm.
I mean, in computer vision these days, you can do a lot even without really understanding the algorithms. There are great libraries out there which help you like implement something in 10 lines of code. Um, so if you're from a developer perspective, you can do a lot without really understanding the math, and there are many people who do that. But if you really want to understand the algorithms and study deeply about these subjects, then yes, math and linear algebra is important.
Okay, that's very informative. So now we got to know what you did in your first year, which was nothing much according to you, like from a technical
Yeah, I
progress
was I was
perspective. Yeah.
volunteering at IEEE though. I
Oh,
used to
okay.
spend
Okay.
time at like creative committee, attending workshops
Mm-hmm.
because it was fun. That's it.
So, what kind of volunteering did you do there? Like, and like most and more, I think that's how you get into IEEE, right? I mean, from a volunteering perspective, like first year you are generally making your inroads through creative committee and helping for Siberia and Tuxedo, and after that you get into the more technical aspects of things. Was that something true with you as well?
Yeah, I don't think I contributed much to IEEE volunteering on the technical side. But generally, in my first year, I used to volunteer in the creative committee for like drawing things for the festivals to create artwork. And I also joined the editorial team at IEEE, which I was a part of for the rest of my time at SJC. They make the magazines, if you've seen them,
Mm-hmm.
and
Yeah,
that
I would
was
also contribute a little sometimes here and there. Like I was busy on the other side of IEEE. Whenever I could find time from there, I would also make a point to contribute some articles. I don't know if
yeah,
you have
yeah,
read them. Yeah.
yeah. I think I remember some of your articles.
Okay. So you were in editorial board, which meant like a lot of graphics, editing, reading, writing, and I think you would also contribute some few articles to the magazine. So did that aspect anyhow help you for your writing during GRE?
Yeah, it does help writing, although I mean you only do it for like maybe 2 weeks for each fest, um, which is twice or thrice a year. So it's not a lot of writing if you really want to become a good writer. And I don't claim to be a good writer. I'm not really good at it. I at the Ed board, I used to help more with graphic design.
Mm-hmm.
Um, so yeah, but it does help. Like for people who want to use some creativity to explore graphic design can do so, and those who like reading like technical articles and maybe also writing them, um, I think can also contribute to the editing side of things.
Okay, so Edboard is not your secret for the humongous score that you got on GRE and verbal.
uh, Not much, but I was always into reading. I think ever since I was a kid, I used to read a lot, mostly fiction when I was a kid.
Mm-hmm.
Now some technical stuff as well as fiction. So
So
it's
so
always
do you
been a hobby of mine.
okay? So do you have any recommendations of books that you would like to say out, like which you like the most when you were reading?
Fiction, I'm a big Dan Brown fan. I don't know about you.
Mm-hmm.
Um, but I used to read a lot of like mysteries, detective stories. So like when I was a kid, all the
Mm.
famous five series and Sherlock Holmes,
Yeah,
and
yeah,
gradually
I like
moving on to
Sherlock
like
Holmes.
gradually moving on to like Dan Brown. And I don't
Mm-hmm.
get a whole lot of time to read. I wish I had
Mm-hmm.
more time. But um, yeah, those that's the kind of books I like reading.
Okay, that's very interesting. Probably I should. I think I've read the Da Vinci Code a little bit half, and then I probably lost interest in it and went ahead and watched a movie on the same book.
Oh,
So
I didn't watch the movie. I actually read
mhm.
the book and it was amazing.
Yeah. It's. I think the books have more details than what it was shown in the movie because there were some aspects which were very nuanced. I can imagine how it would be brought out in a book.
Yeah.
So more about more questions on GRE. Like, what was your practice or what was your preparation like for GRE? Like I know, like I had a chance of getting to know from your roommate when you were preparing for your GRE, Ashish Farande. Like you were juggling a lot of balls there. You were in your final year. You were doing an internship at Amagi, right?
That was after I gave
Okay,
the
so yeah,
GRE. Yeah.
sorry. Okay, so that was when you were doing internship at IIC or Toyota, was it?
I think it was Toyota when I
Yeah.
was roommates with Ashish. Yeah.
Okay. So you're preparing for GRE, you were preparing for GATE, you were doing college, whatever day-to-day stuff was there, and you were preparing for interviews also, the campus placement interviews, and you were doing an internship.
Uh, yeah, I think final year was really hectic for me.
Mm-hmm.
I didn't really do all the things you said I did. Some of it less, some of them more. Um, and yeah, time management is important. And it's if you're one of those who has figured out what you really want to do, you can really focus on that and ignore the rest. But I don't think I was one of those lucky people, so I tried to do a lot of things.
Mm. So you didn't want to miss out on any of the things.
You can miss out on some things. Like now, I don't think like gate preparation is helpful anymore to me. So if I knew
Mm-hmm.
back then I would have focused on what really mattered.
Mm-hmm. So what got you to like tilt towards your masters in in abroad in US compared to like getting it from an Indian college, or like what was it, great score in GRE, or was it from an opportunities perspective, or like what was it?
There are multiple things. So yeah,
Mm-hmm.
firstly, I wanted to pursue robotics, so there are
Mm-hmm.
more opportunities here, and the robotics programs in India are still very nascent and like they're just coming up.
Mm-hmm.
So yeah, I thought it would be great to study here. That's the first reason, and the second reason was also GATE is really hard, and I like I mentioned, and I don't think I understand the testing criteria a lot because even if you have to do, say, specializing controls in later on, then you still have to study all the circuits and all the things in ECE which are not controls. So
Mm-hmm.
these were things I hadn't enjoyed much, and I thought maybe I shouldn't really worry about studying them a lot and preparing for it.
Okay, so you are saying GRE is easier relatively, and that was primarily because Gate has a lot of components of testing in which one might not be really interested in, and that is something that might reduce the performance.
Yeah, you need to be really dedicated to do well in GATE. I mean, the competition is huge,
Mm-hmm.
um, and there are very few opportunities. So I don't want to discourage people. It's still possible. There were some people from our batch as well who made it, and they're like studying at IIT Madras, IIT Bombay, and all now. Um, they've hopefully finished studying. But it's still possible. It's just something I chose not to do.
Okay, okay. So how did you prepare for GRE? Like, what was your like day to
Um,
day regime?
I think I decided that I would attempt the GRE when I was in my fourth semester, I think, and I started going to these classes because I was too lazy to do research by myself. So I attended these classes at Vista Mind. I was
Mm-hmm.
just like I was still in my fourth. Was it fourth? Um, no, it wasn't fourth. It was sixth. Sorry. Yeah, I was in my sixth semester, third year,
Mm-hmm.
when I started taking these classes, and I decided that I would attempt the GRE. So um, I would just attend the classes for what they were. I was not really studying at that point. Um, I was maybe trying to improve my vocabulary a bit, but I wasn't putting any hours into studying. Like we mentioned, I was working on Yantra and all that. So if time permits, I would just go sit in the class. That's all I did in my sixth semester. But once I finished that semester, I started internship, and that's when I started spending more serious time studying. Um, After my internship during the day, I would spend like a couple of hours in the evening, like trying to write something or like improving my vocabulary, practicing some quant. And then after my internship, I think I studied or like I prepared more seriously for about a month or something before I gave the GRE. So this is my perspective of it, but different people might need different amounts of preparation for that exam.
Hmm. So it's basically like it's not like it's like one thing that fits. It's not a shoe that fits everyone, and it's basically like whatever makes you comfortable, and you need to have some understanding of yourself and find a process that works out for you, especially when you're preparing for GRE.
Yeah, that's right. You should know how fast you can read,
Mm-hmm.
what your vocabulary is, and then estimate how much of work that you'll have to put in before you can do well in this exam. I mean, that
Mm.
being said, it's just an exam. It's not too hard, I feel. I mean, it's unfair for me to say it. Um, but it doesn't it doesn't really matter in the grand scheme of things. Like when you look at your application packet for like your
Mm-hmm.
masters,
Mm-hmm.
the GRE is just a number which they probably use to like filter applications.
Mm-hmm.
Um, there, I think universities these days are considering removing the requirement because it doesn't really say much about how successful you'll be in your
Mm-hmm.
masters or in higher studies. But I think the way it helps them is it gives them some number to judge your aptitude coming from an education system that's completely different from theirs.
Mm-hmm.
But this is just like judging some personalities, and it's unfair to many people. But in my opinion, I think if we are in engineering, we learn a lot of math, and we
Mm-hmm.
should be really good at least on the quantitative side of it. And that's what most universities look for. Like
Okay.
they see whether you have a quant score of like 166 or 167 or higher. Um, Out of 170, and your verbal score they don't really care much, um, as long as it's like above 150 or 140. I don't remember the numbers much,
Yeah, I
but
think individual colleges have individual thresholds. For Georgia Tech, I remember the break was like 146 of verbal and I think 155 in quants.
yeah, I would urge people to do much better in quant and focus on that.
Mm-hmm.
Verbal, the amount of preparation, like I said, would depend on how good you are at it when you start.
Okay. So do you have any tips and tricks there for people preparing for GRE of what has helped you specifically to, like crunch probably like how many words did you learn? 3,000 words? 1,000 words?
I really don't remember the numbers, but I learned a lot of words. um,
Mm,
I don't think I remember them anymore either. Um,
yeah.
so yeah, I think that's a good tip. You really have to know the words. There's no other way to do it. It's sad that you have to learn so many words. You don't often use them. Some of them are actually common here. Like I find some of these words are more commonly used in by Americans. Um,
Mm-hmm.
so it comes up in day-to-day conversations, but most of them are not.
Mm-hmm.
So it's just something you have to do for the exam. You have to learn the words. And
Yeah.
another tip, I think, for writing, it really helps to like practice writing. I've seen people get good writing scores without really practicing much, but for
Mm-hmm.
me, I used to like practice writing a random essay like alternate days or something.
Mm-hmm.
When like in that last month that I was preparing for GRE, because it really makes me comfortable writing, because I'm someone who likes to think a lot for each sentence that I write, whether it's correct
Mm-hmm.
and how to structure my essay, like think about paragraphs and stuff. And
Mm-hmm.
in the GRE, you really don't have much time. You have to like quickly go
Correct.
write something
Correct.
good. So
Yeah.
the more you write, the faster you get at it.
Yeah. So how many essays did you like write during practice? 15, 20, more than that?
Yeah, I think about that. I don't remember numbers again, but should be about 20 at least.
Okay. Okay. So what factors did you consider when you were applying for colleges?
Yeah, that's a good question. I think I was not um, great in my choices of which colleges to apply for. I think given another chance, I would make better choices. At that,
Would you have applied for MIT?
no. uh, I mean, you could if you are very ambitious, but I wasn't that ambitious. Uh,
Okay, yeah, go on.
um, I think I kind of neglected the financial aspect of it. Like, not all universities are very affordable. Um, it could depend on like people's personal uh, background as well, but for different people it could be different. So for me, not all universities were super affordable, but I still applied to them.
Mm-hmm.
um, I think I could have saved on some application fees if I thought about that as well. um,
Okay.
or maybe applied to other universities or something. But yeah, answering your question, the factors you need to consider are for a master's program. Um, you need to think of like if you first have to decide what your interests are. So
Mm-hmm.
you should know like which area you want to study in. And second, you need to look up like universities that have good programs in that area, good professors teaching courses in that area, good labs to work on if you want to work on research in that area.
Mm-hmm.
And then you probably also have to think about whether you want to do research or a PhD going forward versus do you want to work in the industry. If you're going to work in the industry, you should probably try to choose universities which have better career opportunities.
Mm-hmm.
um, that being said, you if you're really good, I think you can apply online from every university and still get good opportunities. um, Other than that, I think I would really encourage people to apply to public universities over private universities
Mm-hmm.
because it really helps you financially. You get a
Mm-hmm.
lot of assistantships and like financial support in the university compared to private universities where you don't have as much financial support.
Okay. So did you get any financial support through like teaching assistantships or research assistantships when you were at Georgia Tech?
Yes, I did. So I my tuition was for the 4 semesters that I was at Georgia Tech.
Mm-hmm.
I only paid tuition for the first semester. Luckily, I got some. I think I was a research assistant for a couple of semesters and a teaching assistant for 1 semester.
Mm-hmm.
So that covered my tuition, and it also pays a stipend every month that like if it depends, different universities do this differently,
Mm-hmm.
and at Georgia Tech the way it is, it covers the whole of your tuition and you get a little bit of stipend, which for a TA it's enough to like spend on your living expense. And if you're a research assistant, the stipend might be a little higher and you might also save some money.
Okay. So stipend really helps, and definitely being one of the assistantship really helps because you don't have to pay the fees of the I
Yeah,
mean the tuition fees of the college, which is the major proportion of your total fees. So how did you approach these people to like give you assistantship under them? Like what was the plan, or what was it that you told them about yourself?
I think there were opportunities that I got. And there are, and if you try really hard, I think there are enough opportunities for most people.
Mm-hmm.
Um, yeah, so if I have to go into details, like for research assistantships, if if you've done some really good research in your undergrad and have published or something, and you contact a professor
Mm-hmm.
before you start at the university, and if they like your research, then it's and they have funding for a project that is going on, they might give you an assistantship in your first semester itself, which is great. But
Mm-hmm.
I think most of the people who applied with me did not really have that great research experience before masters, and so we we were we couldn't really get research assistantships in our first semester. So I started working on research with a professor in my first semester, and he kind of liked my work, so he hired me as a research assistant in my next semester. That's how it
Mm-hmm.
worked for me. For teaching assistantships, an easy way of getting them at Georgia Tech is to take the course, especially if it's a if it's a CS course and if it's offered to a large number of students, then
Mm-hmm.
it needs a large number of teaching assistants to correct homework and stuff. So it's really easy if you've taken the course, you can and you've done well. You can just approach the professor and say, I'd like to be a teaching assistant, and it's very likely you'll get it.
Mm-hmm.
Um, but if you haven't taken the course, but have, and I know some people who did this in their first semester itself and got like teaching assistantship for their first semester,
Mm-hmm.
and that way they were like funded for their whole program, so they paid nothing. Um, so if you have taken a similar course in your undergrad
Mm-hmm.
and you're good at it, you can still reach out to professors who are teaching such courses. Um, we should probably be aware of the rules of being a teaching assistant. For us, we have it has to be a course that's taught,
Yeah.
I think, in the final year of undergrad or above. So it has to be either a master's level course or a final year undergrad level course.
Okay. I think that is specific to Georgia Tech, right?
Yeah,
I
that is
mean,
specific to
yeah,
Georgia Tech. I don't know
yeah.
about other universities.
Mm-hmm. Mm-hmm. So you said you did research in your starting from your second semester at Georgia Tech, and that person, like hired you for as a research assistantship for research assistantship, and from there on you were able to like move on and get more exposure in the research domain. So did you have like when you were choosing Georgia Tech, did you have this person in mind that you want to do research under him? And was that one of the reason that tilted your acceptance of like
Yeah, I know
choosing
you're
Georgia
asking this question because you know the story about me. So, yeah,
Tech?
basically,
Yeah,
I
it
mean,
is for the viewers.
so I mean, generally, when you choose a university, I think most people look at professors in the university, and uh, and there are certain professors that you like or like you want to take courses from or you want to work with.
Mm-hmm.
And so one of the problems that I was working on in my initial days in robotics was called SLAM, which stands for simultaneous localization and mapping. Basically, it's a problem where the robot has to, let's say you have a robot in a room. You
Mm-hmm.
don't really get good GPS signals in your room.
Mm-hmm.
So how does the robot figure out where it is in the room? So it does so by like building a map of the room, looking at the image that it's getting from a camera, and
Mm-hmm.
then trying to compare the image to the map and then finding out where it is in that room. So I was working on this problem, and one of the professors who had pioneered an approach for this problem, his name was Frank Tillard, and
Mm-hmm.
he was a professor at Georgia Tech. So I had become familiar with his work in undergrad, and he was one professor I really wanted to work with when I applied to this university. So I think when I approached him for the first when I came to Georgia Tech and I approached him initially, he said, "I don't really have my basics right yet, so
Mm-hmm.
take some courses, take some courses here, and then talk to me again later in the future."
Okay.
So I did that, and then he was happy to take me on as a student, and I enjoyed working with him. I think yeah, that meant a lot for me to work with someone I kind of idolized.
Mm-hmm. So SLAM is basically it's one of the principles or the algorithms that's at the core of self-driving. Is that right?
Yeah, it's used heavily in self-driving as well,
Mm-hmm.
but although um, to different scales. So people may not really realize it, but if there are any rich folks who have the most recent iPhone,
Mm-hmm.
it also uses a lot of SLAM. Like if you're doing all the AR, um,
Oh, okay.
so yeah, I know you're a big fan of iPhones. So
Yeah,
yeah, uh,
but I
it
didn't know this, and I've never used AR on my phone.
Yeah, if you're using AR anywhere, it uses
Mm-hmm.
SLAM to figure out where the phone is in that room. So it's used in AR, and it's also used in self-driving when a car is driving on the road.
Mm-hmm.
You have GPS in self-driving, so that really helps you.
Mm-hmm.
But GPS has its precision limitations. So you use slam in a very local way. So when you're on a street, you use slam to like reason out which precise point you're in.
Mm-hmm.
Um, but you get a prior about like where you are using GPS.
Yeah. Okay. So that's I think that's a very interesting and very satisfactory story. Like you work on Slam in your undergrad, and 2 years later, you get to work with the person who pioneered Slam, and now you are at a company that is using Slam in a significant way, and I think that's a very good trajectory that you have put forth for yourself, or like you have achieved for yourself.
Yeah, I think I was really interested in the problem, and it
Mm-hmm.
I kept moving towards it. That's probably why I ended up here. That being said, there's still a lot about the problem I don't know, and I'm still learning.
Mm-hmm.
I just started working on my job like 3 months ago. So not 3 months. Oh my God, I'm losing track of time. So it was six. It was 5 or 6 months.
Okay.
Um,
Okay.
so
Mm.
yeah, there's still a lot for me to learn, and
Yeah.
I wish I could have actually contributed better to research working with Professor Frank Tillett.
Mm-hmm.
Um, a master's program, like you know this as well as I do, that it's you have to juggle many things during your master's as well, and you may not have a lot of time for research.
Yeah. Yeah. So talking about research, like how do you think research is different when you're doing it here in United States or like at Georgia Tech, and what was your perception of how research was done when you were back in India?
I think I really didn't know much back in India. I had done some research internships at IASC and all, but I did that when I was in my second year, and I did, I think I learned a bit about how researchers work, but
Mm-hmm.
I was in no way a good researcher, or I wasn't good at research when I was in undergrad, and I mean, I think the way our system is structured, um, there's less there's less motivation to do research, and there's more motivation to just get the marks.
Mm-hmm.
So, or like study for placements and get the job, which is important. I don't deny it. So yeah, I really didn't know much about how research works. And I think when I told you I started working with the professor in my first semester, also, I don't think it took me a while to really understand how it works, how to communicate to professors, how to approach writing a paper, or like how to how to phrase a research problem, how to conduct an experiment. These are things I had no idea about when I was in undergrad.
Mm-hmm. So now you have a better idea
I have a better
of that.
idea. I'm not claiming I'm good at it.
Okay. So we have some questions from the participants. I'll some of them you might have answered, but I'll just go over them so that we can you can like touch upon them more specifically. So this is a question. The first question is: Have you worked in a stereo vision? Have you worked in stereo vision specifically in pseudo lidar stuff?
Uh, yeah, stereo vision. It's interesting you mention it. I am currently working on stereo vision at Waymo. Um,
Oh, okay.
so yeah, pseudo lidars. It's pseudo lidar is a very vague term, but I don't
Hmm.
know what the question is about. Do you want me to talk about stereo vision? Or?
Yeah, I think you can touch upon what you do on stereo vision right now.
Stereo is a problem where you have, it's again there in an iPhone where you have multiple cameras and you're trying to
Mm-hmm.
estimate the depth of a point using
Mm-hmm.
two cameras. So
Mm-hmm.
um, you could, there are many, basically any robot or anything. needs to know the depth and
Mm-hmm.
to get the 3D environment, because you don't get it from a single camera.
Correct.
So what you do is you have two cameras, and then you kind of estimate where each of these cameras are relative to each
Mm-hmm.
other. So you need to know the relative rotation and translation, and that process is called stereo calibration, and it's a really important step that goes into stereo. That's also kind of related to what I work on.
Mm-hmm.
And the second step is, okay, once you've calibrated them, how do you get the depth? Um, so there are interesting like depth estimation algorithms. There's a lot of deep learning also going into it today. Like people are trying to estimate depth using a single camera also, but that's
Okay.
generally not sufficient for a self-driving car.
Mm-hmm.
Um, so yeah, we use a mix of like both deep learning based as well as like classical stereo vision based approaches.
Interesting. Interesting. So I think the single camera stuff that you mentioned, it gets used in the Google Pixel phones, right? Where they are
Yeah,
able
yeah,
to get this portrait effect by
yeah.
just using one camera. Hmm. Yeah, that's very cool. So there is another question. I think this you are probably the right person to answer this. It's basically, is there any future in computer vision just after graduation? So that's the question. But before you answer that, I would like you to tell what was your hypothesis for going directly into masters after your BE graduation, and how did it fare? And do you think having an exposure to full-time job would have given you any advantages? Please touch upon this first, and then tell us about like if there are any opportunities directly on computer vision directly after that, after graduation.
Sure. So I think my hypothesis was that I was my first option was not working in the industry um, in India,
Mm-hmm.
and the reason is because I wanted to do robotics and computer vision, and there were really no companies who come to Georgia Tech to hire students. I'm sorry, who come to SJC to hire students for doing that.
Mm-hmm.
So you can still maybe apply. There are some startups who do work on this, so you have to do a lot of research, and I mean like research companies, and find out and apply to them. So you could
Mm-hmm.
do that. um, to me, I thought if I'm not working on what I want to be working on, then it's probably not going to be useful to me. So
Mm-hmm.
um, because even here, when you're applying to jobs, they look at relevant experience. um, you
Okay.
can't you let's say I did web development in India, I wouldn't have it wouldn't have helped me much in applying to a robotics company. But
Mm-hmm.
on in some ways it might have helped. I would have gotten some exposure to like the production to writing production software. And
Mm-hmm.
I think in the initial days of my job, or like when I interned in the US, that's like something that was challenging for me, was to learn that um, leap of software development from academia to industrial production. Um, and that would have helped. And in other way, if you're not sure about what you really want to do, like even after reaching fourth year, then
Mm-hmm.
I think going into the industry might help open some doors. So that might help. But for me, in both for both reasons, I had a good idea of what I wanted to work on, and I wanted to work on it. That's why I didn't take up a job. Um, and coming to your second question was, does computer vision have future? Yes, of course.
I think it was just after graduation, so I think the person is trying to emphasize on that.
After graduation from undergrad in India,
Yeah, yeah.
um, no. So I think it's not a field where you can like take up a job and then learn computer vision.
Mm-hmm.
So if you already have like good projects and if you're comfortable with the field and you're strong in this area, then yes, definitely. I think, like I mentioned, there are startups coming up in India who are working on computer vision. So you can approach them. Um, and if they like your work, then yeah, sure. Um, so there is definitely there are definitely good opportunities if you just want to continue working in India and don't really want to pursue higher studies. Um, I've seen some people who work, I mean, people who do undergrad in the US as well.
Mm-hmm.
Um, they have they have courses in computer vision, machine learning, and stuff, and they know most of these things by the time they graduate from their undergrad. So if students in India can do the extra research it takes to learn all those things without pursuing higher studies, then yes.
Mm-hmm. Okay, so it just comes down to if you
If you
know
know
how to do it.
what it
Yeah.
takes, yeah.
Mm-hmm. Okay, I think yeah, that makes really good sense. So now this is another question since we are talking a lot on robotics and computer vision. So a person's asking, is there future scope for robotics and CV in India? What do you think?
Yeah, I think there is scope definitely for CV because CV is not limited to robotics, right? There are thousands, like there are numerous applications to CV. There's
Mm-hmm.
medical imaging, there's agriculture, there's lots and lots of applications to computer vision, and I think India can definitely use more companies in that space, and you, people can like I expect the market to grow in that area. Um, Robotics in India has always been uncertain. Like
Mm-hmm.
there are promising applications, like especially in the medical industry, in say personal rehabilitation or like assistance of like
Mm-hmm.
that's one really important area in robotics. It's like assistive technology where you're like assisting impaired people.
Mm-hmm.
um, I think India can also use a lot of such robots, and but it also comes down to like the cost of manufacturing and how the Indian economy works. There could be cheaper alternatives to do something. So I don't really know how the market will fare out for that.
Mm-hmm. So it all comes down to how much the research labs, the country in general is willing to invest and like nurture the talent
Yeah, we
and
need like good entrepreneurs who
Mhm,
can find opportunities to apply this technology and like come up with good products that are like
mhm,
feasible for average Indian.
mhm. So you work in a self-driving car company, and what do you think are the challenges for self-driving car in India?
I think the way people drive in India is the biggest challenge. So I think the key reason why self-driving is developing here compared to India is the difference in driving style. Like here, there are fixed lanes, and you
Mm,
follow lane discipline very strictly. Um,
mhm,
in India, it's not at all the case. So it would be really challenging for using like current AI technologies for a robot to learn that,
mm,
um, learn all the stochastic nature. At some point, I hope AI develops to that extent to like even humans find it difficult to drive in India. So I hope AI develops to that extent at some point, but not. I
mm,
think people would agree with. I'm not an expert in this field, but I think experts would agree that it's pretty challenging to implement something in India. You could like use some areas, like if you have an internal campus. Let's say I was
mhm,
returning at Toyota where they had this private campus and private roads, and
Mm-hmm.
they are very well disciplined, and you have, let's say, vehicles that carry parts from one manufacturing unit to another manufacturing unit. You could automate that and have like a self-driving car there, because it's a very restricted environment.
Mm-hmm. Interesting. So you can start in private areas where there is very less footfall of pedestrian traffic, and then probably scale it up to other areas as the technology matures.
Yeah.
Okay, interesting. So, uh, moving on to the next question, what kind of robotic projects should we have to get good colleges in MS, and do CGPA matters to get good colleges?
Um, yeah, I mean, sadly, CGPA matters. I said sadly because we all know how we can get good GPA at SJC.
Mm-hmm.
Um, but the universities here, it's one of the many numbers they use to judge how good you are compared to the others from India or your
It's a
university.
relative grading
Yeah,
scale, right? Yeah.
it's relative. So yeah, you need to have a decent GPA. You don't have to get S grades in every course. I mean, having anything about 9 is great, I think. Um, and what was the other question?
Um, okay. It was what kind of robotic projects one has to do to get good colleges.
Yeah, so the SLAM project that I described is a good example. Projects that people generally do in competitions like Yantra are also good examples of robotics projects you can do. Um, I think a good way to start is maybe speak to students can speak to professors who teach courses like image processing or control systems in ECE. Um,
Mm-hmm.
I guess there are professors who teach like machine learning in CS as well,
Mm-hmm.
to ask how to apply these things in robotics, and like if they want start working on a research problem or something. You could also go beyond SJCE and like approach professors who are doing research in India or even in other countries. Basically, if you're volunteering your time to do something and they don't have to pay you for doing it, they're happy to give you work. um, but the only caveat is that they're spending some time with you, so they would expect some returns out of it. So I guess if we are willing to work, people are willing to give us problems to work on.
Mm-hmm.
So that's one area. And the other thing also you could do is look at like courses taught in universities abroad or even within India, maybe. I'm not aware of any courses in India that teach concepts in robotics and computer vision. You could try to look for like more advanced courses. I mean, people generally find the courses in Coursera or Udacity first, but
Mm-hmm.
these are not deep enough. Um, if you look more closely, you can find courses from, like, say, MIT OpenCourseWare, which is a great platform.
Mm-hmm.
They actually put up recordings of classes that are taught in MIT. And now, since due to the pandemic, like almost all universities are doing this, or like professors' web pages. If you go to the web page, if they have permission, they might put up like a YouTube link to a class that they taught. So these are like great resources for learning, and they give ideas for good projects.
Hmm. So talking about online, I think we have a question on that. What would you suggest 2020 EC students? I think what they mean by 2020 is like people who are stepping into ECE in 2020. What would you suggest 2020 EC students who are missing out the practical aspects of engineering? He or she, they go on to give an analogy. Now it is just like learning to drive online.
I think that's a good point. I don't know. I'm not familiar with how SJC is dealing with. all the like how labs are working basically. I
Mm-hmm.
think I don't know how the Yantra competition is running this year as well. It's all very uncertain, and this is an uncertain time. So I guess people who graduate now are a little disadvantaged, but it's not a great disadvantage. I think maybe in the initial days of the pandemic, everything was very closed. Um,
Mm-hmm.
I really don't know how SJC is working, but here in the US, I know Georgia Tech has its labs open, and if you need to do any essential research, essential as in like essential to your program, then you can go into the lab and maintain social distancing.
Mm-hmm.
Um, I don't know how things are working in India, but even if labs are not open, I think you can do things that help you practically. Like, I mean, I if for a hardcore circuits person, this might be more challenging.
Mm-hmm.
You can't have like CROs at home, but
Yeah,
uh,
just imagine a mechanical person, like, like he has to get a lathe machine in his home or her home.
yeah.
So,
So for those people, I think colleges must come up with some way of doing this safely.
mm-hmm.
I don't think there's a better way to do it. But for those who are not in those areas, you could still work on projects in like simulation. Robotics, a lot of work happens in simulation. Essentially,
Mm-hmm.
we never implement anything on a robot first.
Mm-hmm.
I was not aware of this much in my undergrad, but a lot of the work that's happening on robotics is like is being driven by developments in simulation. So I think
Mm-hmm.
you can explore good simulators and things like that.
Yeah, talking about simulators, we have a question on ROS development. I know you have worked on ROS because you also helped taught me a few little bit of ROS. I could not learn it, that's secondary. But the question is, how is the scope for ROS development?
So the way ROS is used is it is a great tool for academia. It has many like libraries that are already implemented. Like I spoke about Slam, so it's a good example.
Mm-hmm.
So it has some commands which you can just run and get a Slam pipeline started. You don't have to learn much about how exactly this is implemented.
Mm-hmm.
So that way it's nice, and it also provides some like framework. So in robotics, it's really important to communicate between sensors. So you
Mm-hmm.
have multiple sensors, and each sensor is streaming data. So there's supposed to be a central location where which synchronizes all this, and ROS provides a good platform to do that. So in the industry, some people use it for that framework, um, and still implement their own algorithms on top of it. But if you get into like really good uh, company which is serious about their production, they may not use ROS in production. They generally write their own equivalent of ROS because ROS has some limitations.
Mm-hmm.
Um, but it is definitely something that someone who's learning robotics should learn. I think.
Okay.
I,
Yeah. I
yeah,
think it's
I'm not sure if
I
there are
I
better.
found it very hard to learn ROS specifically. I think it partly it was because I was not very much inclined on, like robotic aspects. That
I
could be.
think the hard part about ROS, maybe people from CS might find it easier to learn.
Mm-hmm.
The hard part is because you see something called CMake file, which we have no idea
Mm.
about.
Yeah.
So the thing is, when we start learning ROS without really understanding system software,
Mm-hmm.
like so, if you find something difficult in ROS, I think you should try to understand more about how this is related to C++ and like probably learn more C++ and like build systems and how system software works. Um, I think it will help you beyond robotics and ROS itself. That if you're really going into software development, um, for the ECE folks who are into software, that will really help.
Just learning how the build systems work and how. different parts of the software gets integrated into one package and
Yeah,
runs
how
in
like
tandem.
software is compiled,
Yeah.
how what do XML files do? Like when I
Mm-hmm.
hadn't used XML files before working on ROS.
Mm-hmm.
I think it's called something else. I don't know if it's a YAML or a XML that they use,
I
but
think it's XML for us because I remember seeing that syntax.
yeah,
And
yeah. So
yeah,
what are they used for and how they
yeah,
work? It's good to understand that before understanding ROS.
correct, correct. Yeah, that's true. I wish I had known this when I was studying ROS.
Yeah, even I didn't know it when I started. I was
Mm.
just like trying to get things working in my undergrad. It's only later when I came to Georgia Tech that I learned a lot of this.
Yeah, I think XML is used in a lot of places. I remember it being used even in Android development, and
Yeah, the CS
yeah,
folks listening to this are probably laughing.
correct, correct. So I could not understand that. Well, the first time, like when I had to develop an app, I could not understand it, and it was because of the build systems itself, which the entire, like the app got stopped because there are so many moving parts. Like I don't know, I think it's again the CS folks are laughing. Like you have in Android, you have this something called Gradle, you have several different aspects in Android which are just doing nothing but just building your project.
Yeah, I'm not very familiar with Android, but I
Mhm.
would trust you that with that.
Yeah.
I think these are things that we should have tried to learn in our first and second years if we knew we would be interested in this. Um, these are like great things. These are really fundamental software stuff that even first year students can learn.
Hmm. Yeah, I think that helps a lot for me personally. I feel a lot of my time was wasted in like figuring out the build system. I think,
Yeah,
like you
uh,
mentioned, it's very important that people who are in like first year or second year, like regardless whether you're in ECE or CS, because at a particular point your concepts and your technologies are going to merge. So having good understanding of how these systems work is very important. So moving on to the next question, I think we have a computer vision enthusiast in the thread here. So this
yeah, I
was the
don't know who this
person.
is.
So this was the person who asked the stereo vision lidar stuff, and he or she is asking you about. Can you see the question? Do you mean SGBM model? I
Yeah,
think you can answer it if you want. Otherwise, uh,
I don't think I'm seeing the question here. SGBM model. Oh, that's something
yeah.
I'm
So
not
I
familiar
think
with.
you gave a distinction between where you're using deep neural networks and you're using classical theories
Yeah,
of
I don't
AI.
think
Hmm.
I'm missing what they mean by SGBM. But in classical, what I meant is um, let's see what's a good example. So there are lots of like image processing techniques that were there even before deep learning. So pattern recognition had good ways of detecting edges.
Mm-hmm.
And if you take any like simple course on computer vision, you learn how depth was estimated from two cameras without using deep learning at all. So
Mm-hmm.
basically you look at a point in the world and you say, okay, this is where it is in my first camera, and then this is where it is in my second camera, and
Mm-hmm.
then use those two measurements to kind of triangulate is the technical
Mm-hmm.
word, but um, to estimate a 3D point. So
You use a lot of mathematical aspects.
yeah, it's not super complex
Mm-hmm.
mathematically. I mean, you would need linear algebra that we spoke about.
Mm-hmm. Mm-hmm. Okay. Okay. So I think we are getting towards the end of the questions that we have. So this is again regarding to your work.
Um,
So
okay, I don't know if it's a problem with my setup, but I couldn't hear what you just said.
okay, can you hear me now?
Yeah, this is better. We had some
Okay.
noise.
Okay, great. So okay, could you describe your work in brief as a CV engineer?
Um, Sure, I'll try to do it in a way that doesn't violate anything. So I'm not allowed to speak much about my work because
Mm-hmm.
self-driving is really competitive and
Mm-hmm.
Waymo is super insecure about the technology that we're building. Um, so, like, um, basically, we, I think software skills are really important. So I use a lot of C++.
Mm-hmm.
Some people use more of Python, but these are the two programming languages we use a lot. The way it starts is we have some problem to solve.
Mm-hmm.
Um, for example, estimating depth is one problem.
Mm-hmm.
There are several others, but I don't want to speak about specific problems we solve. But
Mm-hmm.
it starts with a problem you want to solve, and then the standard approach is to go read more about the problem, look at papers that have solved it, look at what approach they're using. So reading papers is also a habit that I picked up in my master's that I really didn't have during undergrad. I think an advice I could give is to start reading more technical papers from good conferences.
Mm-hmm.
Um, so yeah, that would come after you have gained the fundamentals, of course. And so then you read the papers, you understand the solution, and then you look if they have their code online and see if you can run it and see how good their results actually are. Um, and if you like the result, then you would either implement it yourself, or if permissions allow you. I mean, we at our company we of course implement it ourselves.
Mm-hmm.
But being a student, I think you can, if it's open source code, you can just run it and maybe try understanding that code or using it for something else.
Mm-hmm.
That's one way of doing it. But if you that's how you would do it when you start working in this field. But when you get really comfortable and you're doing like fundamental research, then you come up with a problem with which others have not solved, and then you have some idea, so you go about writing code yourself. So in
Mm-hmm.
computer vision specifically, I think I mentioned software skills in C++ and Python. Other
Mm-hmm.
skills, if you want to do deep learning, is to really understand like data wrangling. I
Mm-hmm.
think a lot of what I personally don't do a lot of deep learning at work. I work on more classical approaches. I do some deep learning, but there are people who do it a lot more, and they generally spend a lot of time curating their data set. Like basically, deep learning is coming up with a model which learns what is there in your data set. So no model is better than the data set is a good quote. And people
Mm-hmm.
spend a lot of time just investigating their data, like looking at a lot of plots. So yeah, that's another something. I think most frameworks like PyTorch or TensorFlow that are
Yeah.
generally used come with their own ways of doing this. So
Okay.
I think if anyone's interested, they can just look in that direction.
Hmm. Interesting. So we have more questions, more specifically related to your computer vision work, but I feel it's more helpful for the person asking this question if that person can directly talk to you, because it looks like you need some good thinking
Um,
to answer the question. So whoever's asking this question regarding stereo vision depth estimation,
yeah,
please
I
reach out
mean,
to IEEE Instagram handle and they will pass you on Akshay's contact if that's okay with you, Akshay.
yeah, if it's just one person or a couple of people, they could just list their questions, and I don't think I fully understand everything they're saying, but I'll do my best to give them a response. Yeah, but
Okay.
if more people have such questions, I would encourage them to go to professors who are teaching image processing or maybe ML in CS, and I think they would be very happy to advise them.
Hmm. Yeah. So we have a lot of questions, such in those kind of questions where they're asking for, like projects on particular topics. I think it'll make more sense if you can reach out to Akshay or the people he just told now directly, so that you can, like, find some thoughtful answers.
Yeah, I also gave some. I think there's plenty of work, especially in computer vision and ML. There's plenty of online resources. So there's
Mm-hmm.
Kaggle, and if you look at like the classes that I mentioned from other universities, they generally talk about a lot of interesting projects you can work on.
Mm-hmm.
And sometimes people from other universities even post the projects that they did on their course website. So that's also a good resource. So I don't think seniors would be very available since they're busy with their own work if to like guide and advise. But
Mm-hmm.
uh, if students can do some research and on their own and take some problem to say a professor, maybe it's possible that a professor is not aware of the specific problem that they're interested in. But I think
Yeah.
if they take the problem to the professor um, and tell them these are the approaches and like what do they think or ask for their opinion, I think they would be happy to help. And I
Okay.
think I don't want to name specific professors, but I know professors who are like involved in IEEE currently, who are into this area of robotics and image
Mm-hmm.
processing, and these are good professors who have much more experience than me.
Okay. Yeah, I think you kind of like told exactly who the professor is. So it's just like connecting the dots.
Yeah,
Okay, so we have some rapid fire questions for you. It's basically, I'll give you two, this or that. It's like this or that. So you have
yeah,
to choose
sure.
one of the two. Okay, and with this segment, we will wrap up our podcast. So the first one is Windows or Linux.
Linux any day.
Okay, lab or class.
Uh, Lab
7:30 a.m. class or 3:30 p.m. class.
7:30 a.m. class.
Nescafe or Yampa.
Yampa. I don't know who would choose Nescafe over Yampa.
Okay, 100% attendance or 75% attendance.
I think that depends on the course and the professor. Uh,
Okay.
if it's something I'm interested in and if it's being
Mm-hmm.
taught well, then 100%.
Mm-hmm.
Otherwise, 75 or even less.
Okay. Okay. RCB or CSK.
Um I am a I am not a great cricket fan, but I okay if it comes down to the two teams, maybe RCB.
Okay.
There used to be another IPL team I used to support once upon a time, um, which is neither of them. But if I have to choose between them, maybe RCB.
Okay. Which was that team?
It was KKR.
Oh, okay. Why don't you support them now?
I'm not watching IPL anymore.
Oh, okay. Okay. But you are a
Yeah,
KKR fan. That's nice.
I don't even know what the team is like anymore, so I can't
Okay.
really call myself a fan.
Hmm. Okay. Cool. That. It was very nice talking to you, Akshay. And I think we are almost like 30 minutes over our regular time that we scheduled for this podcast. And thank you for sp- spending your early morning Saturday time. I think we started around like your 7:30 a.m. And thank you for joining us and spending time with us and giving an insight into giving your letting us know your perspective. I'm sure a lot of students who are watching this and who are currently in college find a lot of inspiration and also a lot of help from whatever you have told and spoken from your experience.
Yeah, I hope it helps them. I I've just been able to provide some direction, but they they have to do all the hard work. I hope the professors can help as well. And thank you for being a great host. It was nice talking to you again, and I think you have a lot of great experiences to share as well. You have had a very similar journey as I have, and I think at some point, um, the students might be it might help them if people who are more senior to me could also come on this podcast. I
Mm-hmm.
think there are many SJC alumni who have
Yes.
done great progress in their field, and they're in like great positions right now. I don't really have any personal contacts, but if you're at SJC, I think you're well qualified to do just anything as anybody else. So you should feel pretty confident about yourself. That's all I wanted to say.
Yeah, thank you. Yeah, I think we'll in the days to come we'll have a lot of alumni coming up to this podcast and like sharing their experience, and it's just like I think we are just like this is like episode 5. So
Yeah, I
yeah,
hope it's helpful to a lot of people.
definitely. Yeah. Thank you. Thank you once again, Akshay.
Yeah, thanks for having me. It was nice talking to you.
Same here.